Hello my dear students. Today I am going to represent new topic of electrostatics, that is electric flux and the Gauss law. Okay, this is the most important topic of the electrostatics. First I will see what do you mean by the electric flux, how it can be calculated, and what is the role of the Gauss law in the calculation of the electric flux. Okay, so first, what do you mean by electric flux? Basically, flux is a general word. Flux is a general word. It is not dealing with only electric field. It is the property of any vector field. Let's say it is a magnetic field, electric field, gravitational field, all those fields which have a vector property. It deals with all those fields which having the property of the vector. First, this is the very important thing you should understand. Flux is not only dealing with the electric field. It is deal with what? All the entire field which have the property of the vector. Okay. Now, basically, if I say flux, it means certain amount of energy or certain amount of the field passing through any surface area. This is called the flux. Okay. Let's say we have this is the tap, this is the bucket. Okay, if I put this bucket put down, then number of water droplets falling per second from the tap is known as what? Hydrostatic flux or water flux, you can say hydrostatic flux. Okay, this is what? Number of water droplets. Similarly, if I put 1 meter square cardboard in front of the sun, then number of radiation falling per second on that cardboard, that is called solar flux. Okay. Similarly, if I put a charge Q here, as you know, this positive charge emit the radiation, or you can say electric lines of forces in all possible direction. And if you have a 1 meter square area or any surface area, this is surface area S, then number of electric lines of forces penetrating this surface is known as an electric flux. Clear? I think it is clear to you. The first thing you should know, electric flux is not a particular word, it is a general word. It deals with all those fields which have the vector property. Okay, if I say this is the number of the electric lines of forces. Okay, this is electric lines of forces, and I put a 1 meter square area or something certain area here. Number of electric lines of forces passing through this surface is known as electric flux. If I put this surface according to this situation, then what will happen? इस situation में देखिए आप, maximum number of lines of forces will penetrate it. Okay, but in this situation, if I put it this one, then what will happen? Minimum, there is no flux passing through it. There is no flux, no electric lines of forces penetrating. It means the flux through any surface just not on depends on the amount of electric lines of forces. It also depends on the surface area and the angle. Flux depends on the surface area and angle also. Okay. So this is the actual meaning of the flux. Now, we will see how can we calculate the flux. So you can say electric flux is number of electric lines of force passing through or penetrating through any surface. Now the next question is, how can you calculate this number of electric lines of forces? As we have seen, the number of electric lines of forces is depends on the area, okay, and orientation. ये surface है, surface को आपने ऐसा रखा. Is in this case maximum number of lines penetrated, but in this situation minimum. It means the flux depends on what? Orientation and the nature of the surface also. Area of the surface. Okay. So this is the actual meaning of the flux. Now we will see how can we calculate the flux through any surface. So flux depends on first point area, second point orientation, or you can say angle. Say it is theta, orientation. Okay. So basically Gauss gives the idea of calculation of the flux. किसी surface के थ्रू flux कैसे calculate करना है, किन बातों पर वो depend करेगा, वो इन्होंने बताया. तो पहले first I will see how it is depends on the area and orientation. Let's suppose this is number of electric lines of forces, or you can say uniform electric field. This uniform electric field is drawn in form of a parallel line. Parallel line shows the uniform electric field. Okay. If I say this is the surface, any surface, let's suppose its area is D. Okay. And its normal makes certain angle. Its normal makes certain angle theta. इसका जो परपेंडिकुलर है, इसने यहां से कितना एंगल बना रखा, थीटा डिग्री पर. अभी आपने देखा, देखिए ध्यान से, इलेक्ट्रिक लाइंस ऑफ फोर्सेस पासिंग दिस वन, आपने सरफेस को ऐसे पुट किया. ओके. तो मैक्सिमम रेडिएशन पासेस, इन दिस केस मिनिमम. अब आप सरफेस का नेचर चेंज कर दें, ऐसे बेंड कर दें, किसी पर्टिकुलर एंगल पर बेंड कर दें, देन व्हाट विल हैपन, देन फ्लक्स इज कैलकुलेटेड एज फाई इज इक्वल टू, flux is represented by symbol flux phi. Okay. And it is given by E dot with A. E is a electrical field vector and A is a area vector. And as you know, dot product of any two vector is given by cos theta. So phi is equal to E dot A. It means phi is equal to EA into cos theta, where theta is the angle between electric field and area vector. You have to focus on this one. Okay. Because in so many questions, area vector plays very important role on the calculation of the flux. Okay. So this is what is electric flux. How can you calculate the electric flux? Phi is equal to E dot A. Now we will see area vector. Okay. In previous classes, you have calculate the area of the so many figures. For example, let's say area of a square, area of a parallelogram, and area of a rectangle. Okay. Then only you have calculate, at that time you have calculate only the magnitude, but area is a vector quantity. If I say in a Cartesian system, this is a rectangle whose size is 3 centimeter or 3 meter, or this is 4 meter. Then what is the area of this rectangle? You will say simply area is equal to length into breadth, then 3 into 4. This is 12 meter square. Clear? So this is only magnitude. And I am saying what? Area is a vector. Then what is the direction? Because if any quantity has vector quantity, then it must have some direction. Then how can you calculate this one? The actual right way of calculation of this one is 3i cap into 4j cap, where I cap is a unit vector along x-axis, so j cap is along the y-axis. And you know 3 into 4 I cross j. In 11th class you have studied 12. I cross j is nothing but it's a k cap. Okay. It means the area vector is always perpendicular to the surface. Area vector is always perpendicular to the surface. Let's suppose ये dimension है board की 3 meter 4 meter. Its area vector will be perpendicularly outward. ऐसा. Okay. Perpendicularly outward. Up now the question is arises, the perpendicularly should be inward also. उसके उस साइड भी, बोर्ड के अपोजिट साइड में भी तो परपेंडिकुलर हो सकता है, और इस साइड में भी परपेंडिकुलर हो सकता है. सो यहां पर आप क्वेश्चन फिर से देखिए. इफ आई एम डीलिंग विथ टू डायमेंशनल सिस्टम और ओपन सिस्टम और क्लोज सिस्टम, देयर इज वन साइन कन्वेंशन, ओपन सिस्टम एंड क्लोज सिस्टम. If you are dealing with open system, you can take it both, inside and outside, both. But if you are dealing with closed system, let's say we have a cube, 3-dimensional system, okay, and we have placed some charges inside the cube, then its area vector always calculated perpendicularly outward. Always remember, when you are dealing with the closed system, then your area vector should be always perpendicularly outward direction. So this is the very important term which deals on the calculation of the electric flux via Gauss law. Is it clear? Okay. So always remember, for if you are dealing with the closed system, then area vector is always perpendicular to normal surface or perpendicularly outward. Okay. Listen. If we have a cubical surface, let's say its side is A, and we place a charge Q, and uniform electric field is elongated in x-axis. Let's say this is x-axis, y and z-axis. Okay. Now in this situation, we have to find out from which surface the flux is passed. Okay. This situation is similarly as you are sitting in a room which are in shape of a cube. अब cubical room में बैठे हुए, you have 6 faces: front surface, back, top, लेफ्ट, राइट एंड बॉटम. इन सारे 6 फेसेस में से कितनी सरफेस ऐसी होंगी जो इनसे फ्लक्स को पास करने देंगे, ये आपको कैलकुलेट करना. तो बेसिकली फाई इज इक्वल टू, आपने लिखा ए डॉट विद ए कॉस थीटा. इफ थीटा इज इक्वल टू 90 डिग्री, ई ए cos 90, तो cos 90 is 0, therefore flux will be 0. It means simply we can say if area vector and electric field makes perpendicular to each other or makes 90 degree, then there is no flux passing through the surface. This is very important one. It works in so many questions. Okay, now listen. From this surface, centered part, electric field is this outward direction and area vector is perpendicularly outward. This is the cube. Cube का perpendicular क्या हुआ? इस डायरेक्शन में. This is A. It makes angle 0 degree. दोनों वेक्टर एक ही डायरेक्शन में वर्क कर रहा है ना. That's why it makes angle 0. It means यहाँ से फ्लक्स पास होगा. Similarly for this surface, electric field in this direction, but its area vector will be opposite direction. Area vector is always perpendicular to surface. Let's say ऐसा समझो आप. इसका area vector perpendicularly outward. Area vector for this surface is perpendicularly outward. Area vector for this surface is perpendicularly outward. Area vector for this surface is perpendicularly outward. This is the method. Okay. If I consider this surface, the electric field is E and area vector is A. It makes angle 90 degree. Or as you know, if angle is 90 degree, there is no flux. It means यहाँ पर flux कितना हो जाएगा? 0. Similarly here also, electric field is this one. This situation is same as this one. Okay, electric field is this one. इसका area vector this one, perpendicular. So there is no flux. Phi is equal to 0. So this is the methodology which you have to apply on the calculation of the flux. Okay, it means out of 6 phases, only 2 phases, right side and left side phases, will pass the electric flux. Otherwise 4 surfaces will pass 0 flux. Okay, this is the methodology. So you have to remember it. If angle between the electric field and area vector is 90 degree, it means it does not allow any flux to pass. Now the topic is Gauss law. So Gauss law basically deals with the calculation. It gives calculation of flux, electric flux. Okay, according to this law, if I say we have a charge Q here and this charge is enclosed by any surface, okay, then number of electric lines of forces from this surface, listen, इस direction में देखिए, the number of electric lines of forces, it means phi, which is denoted the flux, phi E, electrostatic flux, is given by surface integral of E dot ds, and which is equal to 1 by epsilon naught times of sigma q. This is the Gauss law. Okay, electric flux or number of electric lines of forces passing through any surface is equal to surface integral of the electric field or area vector, and which is equal to 1 by epsilon naught times of sigma q. Sigma means algebraic sum. Sigma means algebraic sum. What is the meaning of algebraic sum? You will add up according to their sign. If I consider this surface, okay, in this surface there is so many charges, minus 2q, 3q and 4q. And if I ask calculate the electric flux passing through this surface, then you will say phi is equal to 1 upon epsilon naught summation of all the charges. So minus 2q plus 3q plus 4q. It will come up 437 minus 2, that is 5q. This is the actual meaning of the algebraic sum. When you use the sign, then it is known as an algebraic sum. This is the Gauss law. The Gauss law gives the idea of calculation of the electric flux through any surface. Okay, if I ask, let's suppose this is the charge q, and as you know, this charge release all electric lines of forces in all possible direction. Yes, and I consider here a surface named as S1, and there is another surface with larger surface area, that is S2, surface area S2. And if I am asking calculate the ratio of the flux through surface S1 to the S2, then what will be your answer? I am asking calculate the ratio of the flux passing through the surface 1 or surface 2. This situation is same as this is the point charge. मैं यहाँ पर खड़ा हूँ एक छोटा एरिया लेकर के, आपका कोई फ्रेंड और खड़ा है आगे, वो बड़ा एरिया लेकर के खड़ा हुआ. तो what is the ratio of the electric lines of forces passing through these two? Okay, this is the very important concept. Now listen, this answer should be what? 1:1. Why? आप देखो ध्यान से, there should not be any electric lines of forces which penetrate it but does not it. कोई भी इलेक्ट्रिक लाइंस ऑफ फोर्स ऐसी नहीं होगी जो इस सरफेस से तो पास हो बट इससे ना. ओके, बट ऐसा तो नहीं होगा ना कि कोई सरफेस गई इससे पास हुई बट ऐसे मुड़ गई, ऐसे गई फिर वापस इधर को आ गई, ऐसा नहीं हो सकता. बिकॉज आपने पढ़ा हुआ कंटिन्यूअसली पाथ को फॉलो करती है. इट मींस जितनी इलेक्ट्रिक लाइंस ऑफ फोर्सेस यहां से पास करेंगी दैट शुड पास थ्रू हियर आल्सो. Number of electric lines of forces passing through the surface S1 must be equal to the passing through the S2. Therefore, we will see same number of electric lines of forces are passing. Hence, ratio through the flux will be what? 1:1. Clear? So this is very important concept. So many numerical part of the questions has been asked based on this concept. This is all about the flux. Now, if I ask, this is the square shape, we put a 2 coulomb charge here, and this is the circular part here, 2 coulomb. Then what is the flux passing through these two surfaces? Calculate the flux passing through the square surface and flux passing through the circular part surface. Then your answer should be what? It is same. Why? Because electric lines of forces or electric flux does not depends on the what? Nature of the surface. आप surface के nature को square कर दीजिए, rectangle कर दीजिए, circle कर दीजिए, parabola कर दीजिए, whatever. Okay? So this is the concept. It means जितनी electric lines of forces यहाँ से पास होंगी उतनी ही यहाँ से भी पास होंगी. So we will say flux is what? Same. Okay? So this is the concept of the electric flux and Gauss law. This is very interesting topic. Very important concept. Okay, I think it is clear to all of you. Okay, thank you.